Okay, this next function is a cubic. It's a little bit more involved than the previous one, but the concepts are exactly the same. The first thing we're looking for is the x-coordinate of the stationary point, so we find the derivative and set it equal to 0. So the derivative is going to be 3x squared minus 2 times 17 on 2 is 17, and the 2 decreases to 1, so minus 17x plus 10x. And we want that...
Yeah, the 5.
Oh, plus 10. Thank you. Thank you. Yes, plus 10. Okay, we want the derivative equal to 0, so we let 0, so therefore 0 equals 3x squared minus 17x plus 10. Now, there's at least 4 different ways that you can solve that, but this is not a unit on quadratics. I'm not testing your ability to solve a quadratic. It just so happens that a quadratic has turned up in the middle of this. So please don't do the 10-line quadratic formula solve. Use an economical version of the solution. So use equation solver in your calculator or graph it and find the roots. If you can factorize it quickly and solve it that way, fantastic, but don't spend time. I'm going to use equation solver. And x is 2/3 and 5. All right, so let's test the nature via a sign diagram. So it's a sign diagram of the derivative, which means my critical points are 2/3 and 5. And if you have a look at the derivative, the coefficient on x squared is positive, so it's the happy graph, which means that we've got positive, negative, positive. We draw the lines to show what that looks like. Positive slopes upwards. Our 0 has a slope of 0. Negative slopes downwards. The 5 has a slope of 0, and then positive slopes upwards. So we can see that at x equals 2/3, it's a maximum, and at x equals 5, we have a minimum. So we've classified the points. We just need to find the y coordinates now. So when x equals 2/3, we sub it back into our original equation. So 2/3 cubed minus 17 halves times 2/3 squared plus 10 times 2/3 plus 5. Put that into your calculator and we get 221 on 27, which is approximately 8.19. Then for when x equals 5, we have y equals 5 cubed minus 17 on 2 times 5 squared plus 10 times 5 plus 5, which is negative 65 on 2, or negative 32.5. And from there we conclude, therefore we have a maximum at 2/3, 221 on 27. Pardon? 10 times 5. Yep, fantastic. So we conclude we've got a maximum and then a minimum at 5, negative 65 on 2. And notice the inclusion of the 3 pieces of information. We've got the x, oops, wrong pen. We've got the x coordinate, we've got the y coordinate, and we've got the nature for each point. If you don't include all 3 pieces of that information, then your answer is incorrect.